Yeah, we are good. Okay, welcome guys. Too bad you couldn't join us. Those who are here, thank you for coming. Hopefully this will be uploaded on YouTube. Okay, so today is a combination of lectures. It's not only one lecture in one. It's kind of bits and pieces, putting everything we've done in this course, kind of to wrap up everything we've done in this course. So if you remember, we started by, which was linked to assignment 1, we started with the job to be done analysis, right? That was one technique that allows us an SET, which is social, economic, and technological factors. So these two techniques allowed us to identify opportunity gaps, okay? So that was the first technique. You did the whole assignment on this. And again, from the opportunity gap, we did something called value quotient analysis. So value quotient analysis was very useful as well. Remember the value quotient analysis? So we look at the values, and from the value quotient analysis, what do we identify? The opportunity gap, you know, the gap, we start measuring it. So this is a big thing, obviously something very important for the final, to know how we actually went through the steps from the job to be done analysis all the way to identifying the gap, analyzing the gap, looking at existing products versus the optimal, and trying to justify the need for that specific opportunity. Okay, does that make sense? Then we moved on to something very, very popular. It's called design thinking. You know, design thinking, we spent about 2-3 weeks on it. We had a nice assignment on it, which is the net zero energy restaurant, if you want to call it. So the idea was, how do I use design thinking, which is part of it is empathy. How do I feel with my customer? How do I do this spiral model, if you want to call it, where I go back again and again and again. So I know I feel with you. I understand what you need, you being the customer. I sit with you. I understand and extract from you insights. So insights is a big thing of design thinking. Again, what is insights, or what are insights? Are basically things we cannot see. And, you know, from the empathy, I generate insights. So I know stuff about you, which I could not have known before. And hopefully from these insights, I will actually design something for you. It's what makes it so cool. It's called design thinking. And this course is called innovation and design. Okay? So cool. So that was the journey so far. So continuing, in between we talked about job scoping. I don't know if you remember, we had a whole lecture on job scoping a little bit, where you scope down. We had something called stage gate. And gatekeepers that decide, oh, should I go, don't go? Should I recycle the idea? So that was also one of the techniques that we actually taught. Under that is called NPD. NPD meaning new product development. So any company like Samsung and Apple and all these big companies, they have a department. It's called NPD department. These are the people coming up with new ideas, and they usually end up using the stage gate process. Okay? Cool? Okay. So let's continue along the same line. So when we talk about innovation, we've defined innovation before. We talked about many kinds of innovation. Again, today's lecture is, I uploaded this, by the way, the lecture is uploaded, but this was already there, but in a bunch of other lectures. I kind of summarized these other lectures in one big lecture, about maybe 100 slides, but this is kind of bits and pieces from other stuff. I feel like they are important, okay? So when you talk about innovation or innovative thinking, it's not only about creating a business, and again, it's about capabilities. And you have different kinds of innovation. You don't have only one kind of innovation. Yes, we're going to talk about innovation, but we mentioned some kinds. Anybody remembers at least one kind of innovation before we talked about? A big word. What kind of innovation? The big innovation. What do we call this big innovation? Like the Ubers and the Airbnbs and stuff like this. So we call this? No, but what's the word called? Disruptive. We've talked about this. We've talked about disruptive innovation. Disruptive innovation is I disrupt the whole thing, right? Yeah, I'm doing something like this, A, B, C, D. All of a sudden, something comes out that changes the whole innovation cycle, right? Does that make sense? Give me an example. I gave you a lot, but give me one example of disruptive innovation. That disrupts everything we do. We change the way we do stuff because of that innovation. No. Could be if it worked, but it's not yet, you know. But what changed the way we do stuff? Come on, think bigger in life. What changed? PCs maybe it's not 100% disruptive. It's radical. We call this radical innovation. It's internet. These are a lot of kinds of innovation, but you have to know where they belong. So when you talk about innovation and entrepreneurship, you obviously could innovate. We've talked about this before. In terms of products, you could come up with new products. You could come up with new processes. We talked about this, remember, way back in week 1, week 2. Or you could innovate in services, right? So, or experience, remember? So we talked about all these. So if you divide innovations, again, if you categorize them, you have inventions, new products, services, you invent something. Hopefully you're gonna do this in the final project. Extension, you're actually expanding on a service and product already there. That's expansion. You do not invent anything, just expand it on something. So there is a laptop, and magically I added something here that allows me to do something. You did not invent a laptop, you just added a feature, so you expanded on this. You duplicate. So duplications, you replicate. Again, a good example is Uber and Kareem. Remember we talked about this? This is more duplication in a different setting, different setup, you know, so still a duplication, but you add your touch to it, your creativeness, your marketing. Again, like food on click and talabat and you know, remember there was like a wave here in this country 2 years ago. All of a sudden, there's like 7 companies that do the same thing, you know, or the Uber Eats and ta. So you felt like, obviously, because one succeeded, like, there is an opportunity here in this domain. Okay, synthesis is a combination of you synthesize something, you combine. So there is invention 1, invention 2, A, B, C. I put them together. You know, like I don't know, we talked.
The Walmart that you said where.
Exactly, Walmart, the mechanic and the oil change and the shopping experience all in one. There is like this cooler thing. Did we look at Coolest? This Coolest, it was like a nice invention that has a cooler and a bottle opener, a fridge, a blender, all in one. And they made a lot of money on. That was the biggest selling product. And 2 years ago, you know, if you check online. So anyway, so these are different kinds and different methods. Now, what's important to me, you need to focus on, this is important, okay? So you have different kinds of innovation. So this leads to, there's a lot. If you go, there are a lot of kinds of innovation. But I'm gonna focus on 3 here real quick. You have the radical innovation. What are these? Again, these are breakthroughs. So yes, the breakthroughs, I mean, they kind of change. They're very close to disruptive, but they did not disrupt the way we do stuff. They are radically changing our lives. That's why they're breakthroughs. They call them radical innovations. Again, example, mail delivery overnight, like, you know, the DHLs and the Aramex. These are radical. You never thought. It's so big, you know, it's huge. Change our lives, right? Again, obviously the PCs, personal computers, are radical innovation. You know, you having your own PC at home is a radical innovation. I could keep on going. And again, I advise you to Google this, watch YouTube, read, say radical innovation, let's see examples. There are tons. You can do tons and tons of case studies on this. Incremental, that's the most common. Incremental, again, I increment on something existing. So I have something and I add to it a feature. Then I have something, I add to it a feature, another feature. A very good example for you to correlate with is Gmail. You know, if you go back to email, online email, cloud email, from the Yahoos and the Hotmail, if you had the Hotmail, I used to have a Hotmail. That was one of the most common. And look at Gmail, see how it evolved, right? You know, attachment, then, I don't know, you could add video links, link to YouTube, then you could add, you could signature, I could keep on going, add Google Drive, if an attachment was more than 10 megabytes, automatically change it. Stuff, I could keep on going. So that's called incremental innovation. It's innovation for sure. It really changes how we do stuff. Google Maps, same thing, right? Google Maps, again, you could go back to the normal maps, how it changed, and now you can see, I don't know if you've seen the Google Maps of the future, which integrates the physical environment. You've seen that? So it's not GPS anymore, simply. It integrates, so if I open the camera and the map at the same time, so I would see the road. So if I put my car, I'm driving, I put my phone on the phone holder, and I put GPS, right? It says take left, take right. Now you see a cartoon, right? You see image. Best case scenario, you see a static image like Google Earth. No, now it's a real-time image. You will see the normal road on the camera. On it, augmented are the directions. So go left or go right. You see exactly when you are there because it knows where you are and knows the environment. So that's kind of another step. You know, imagine how cool this is, because it happened to many of us, right? Where you hold the phone like you're in a foreign country, so you go straight. I don't know where I am. I start to figure it out. If you have a camera, all you have to put it like this. it exactly shows you where to take left or take right. I'm just giving you an example. Again, this is called incremental innovation. It's incremental. And many, many, many examples. I could keep on going. Same thing with phones and stages or mobile apps. You see a lot of apps say update, update, update. All these updates more or less are incremental, especially if they do something innovative, something new completely. Does that make sense? Are we cool with the first two kinds? Now we come to the disruptive. Disruptive are the biggest kind of innovation. The biggest. These are innovations that change the way we do stuff completely. They delete everything before it and create a new wave. We call this an innovative, disruptive wave. Okay? So again, disruption in terms of disruptive innovation goes beyond radical. So if you think about radical here, obviously disruptive is the biggest. So they're beyond radical innovations. We're talking about changing the whole industry. You change the whole industry. Again, example, I just put very quick Uber, but you could think about many others. Why Uber? Because Uber changed the whole taxi industry completely. The taxi business is dead because of Uber. If the laws and regulations and all this, obviously in Dubai we still have taxis, but many other countries you feel like they are making deals now. Us, we cannot beat you, you cannot beat me. Let's figure out a way to work together because it changed the whole industry. And I could keep on going with other examples, right? Again, the same thing with Airbnb, right? You know what that is. So again, the hotel industry changed it completely. Now, many people, when they go to countries, they don't go to booking.com anymore. They try to find apartments for people who want to rent it because it's cool, cheap, and has some authenticity to it, right? Authenticity to it. So you kind of feel what the actual culture is. So long story short, disruptive, again, the same thing, digital, right? Digital analog, cameras, digital, deleted everything before it. Everything's digital all of a sudden, right? You don't have any analog cameras, you don't have analog phones, you know, now you have IP phones, right? So the digital wave as well, it could be called disruptive because it changed the way we do stuff. So, okay, so keep that in your head, huh? 3 major kinds. Typical exam question. I give you a table with different kinds of innovation. Tell you where do they belong. You need to know this, obviously. If you understand them, it's easy. Oh, this is this. And justify. Why? If you understood what radical is, what disruptive is, and what incremental is. Sounds good?
Some things fall under more than one category.
Yeah,
it can if you justify. Depends how you justify. If I tell you automobiles, I tell you cars. Tell you cars, for example. Cars, it's radical for sure. Is it disruptive? Depends what kind of car, when, and how. Is it how, you know, like, depends how you justify it, okay? But definitely, it could fall to many. Even if you go to Google and read articles, it's debatable. You could consider it disruptive. I consider it radical. Even among researchers, it's not like written on stone. It's not. That's why when we grade it, 90% will tell you justify. How did you? Why did you say that? Oh, okay, I get it. You might convince us based on your answer, but just selecting doesn't mean anything. It could be anything. Okay, but obviously in terms of hierarchy, we have the incremental, radical, and disruptive. Okay, so this is how powerful they are. Okay. So again, I gave the Kodak example. So Kodak. Do you still remember Kodak? Do you remember it today? Now, is it Kodak? Is it there? None. Bye-bye Kodak. But remember the Kodak moment, right? The slogan we saw. It's a Kodak moment. Because you take a picture with your family. And I remember the yellow camera. I don't know why. Remember the yellow, it has a Kodak in red. Disposable one. They were so famous of this. Even normal cameras. And because they were the leading industry in camera business. They were the leading. We all know that. If you were old enough, you would remember. But obviously what happened? The digital wave. Digital cameras. Phones having cameras. So it killed. Because Kodak used to be incremental. See? So you could play it safe like a company with incremental innovation, right? This is what Kodak did. Every time they added a feature. Something cool. Incremental, incremental, incremental. What came? Disruption, which is the digital wave. It killed completely Kodak. So this is an example of a wave, how we started incremental, and that's a very dangerous game to play as a company. You have to go and think about a better way to do it, and this is how disruptive innovation made Kodak obsolete. Now it doesn't exist. Or if it does, it's very minor segment. Okay, are we good with the different kinds of innovation? Very cool. Are we good? So we've talked about job scoping before. If you remember, the idea of job scoping, we did a small exercise in class. This was a while back, maybe 5-6 years ago. Before we run to the stage gate process, yes.
Incremental.
The most powerful is disruptive, below it is radical, and below the least is incremental. And you have others, but according to these three, if you want to rank them, definitely incremental, radical, and all the way disruptive. So we come to job scoping. You remember when we were deciding on jobs? When you want to do something, you say, my job to be done is find a better way to study for exams without being stressed. Suppose that's a job to be done, right? So we said, looking at this job to be done, we could look at a narrow version of it, or scope, or a wider scope. You know, look at it in general, study for the exam, meaning pass the exam, this is what we mean, right? Or get a degree. So you're looking at very narrow, very wide stuff, you know? Or you could narrow it, you could zoom in a bit. Study for the exam, meaning study for chapter 1, or you know, get ready, stuff like this. You could always narrow it down one by one, or question, or a concept, or learning objective. This is small and small. It's what we call job scoping in general. And obviously, what are we trying to say is we're looking at everything surrounding our job. So our job is in the middle, and we're looking at other jobs that are affected by our job or affect our job. Does that make sense? So our job either affect other jobs or is affected by other jobs. Why do we care? Because, as I always say, you might start with a job to innovate in and end up doing what? Innovating where? Another job. From this exercise. Come and say, you know what? I cannot do this anymore. I want to make a flying car. You know, and I figure out if I was able to make a flying shoes, which is a part of this job, I could make tons of money and change the world. No need for this anymore. So you might deviate. Plus, because sometimes, obviously we call this auxiliary and ancillary jobs, remember? Ancillary jobs that come before our job, okay, or after, depending on how we look at it, okay? So this is what job scoping is. One famous analysis technique when it comes to job scoping, it's called the 9-window analysis. I want you to pay attention. Super. Okay, so 9 windows analysis, it's very similar to the job scoping, but instead of only looking at our job before and after, we look at our job, smaller parts of the job and bigger parts of the job. We look at it in 3D. This is so cool. So 9 windows, my job is in the middle and I have 9 windows. In other words, 3 by 3 matrix, 9 windows, 9 boxes. We're gonna see it in a second. My job is in the middle. So we're gonna look at what we're gonna look at. We're gonna look at the past and the future. That's one domain. This is one of the axes. Okay? A super system and a subsystem. So a smaller piece of it and a bigger. So and a bigger picture of it, like the job scoping, the bigger picture of it and the smaller picture of this. Okay? So this is what the 9 windows is. Super cool, super useful, super famous. So even if you do this and you understand this, and you work in any company that has any idea about innovation, it's nice to put on your CV. You know 9 windows. It's a methodology. It's a practice. So we're going to do an exercise together on this to make you comfortable with this. Obviously, we do the 9 windows so that we end up hopefully with a product or looking at the holistic view of our problem. So our problem, or what we're trying to do, is in the middle. Then we look at the future. How cool this is. Suppose I want to come up with the flying shoes. Let's go back to the flying shoes example. Okay, I don't know why I'm talking about flying shoes a lot today, but I'm wishing we'll have it very soon. Okay, so flying shoes in the middle. So what do you think? That's what? Is it the past, present, or future? No. This is where you got wrong.
What's our idea?
Our idea is the present.
Yeah, it's in the middle.
It is in the middle. That's the present. So when you do the 9 windows, ironically, what you have? You're gonna do, and the past of that is what? Past of our idea is now. In the box, we are the present. The past of it is today, before our idea. The future of it is after our idea. So it's the second version of our idea, if you think about it. So you're already thinking about the next thing, and you even haven't come up with your first thing. Does that make sense? What's that?
Flying car would be.
Could be, or it could be invisible shoes with flying capability or something like this, you know? Could be along the shoes market. But again, we could think about that as well. And then we're gonna have to look at the subsystem, the subcomponents. So if I'm looking at the car, What are the subcomponents? Yeah, subcomponents. What are the smaller things in a car? Engine, tire, screws, chairs, right? Things that make the car. These are the subcomponents. Because if I want to invent a car, I have to invent all the components of it. These are sub. What are the super system? What does the car affect? And a bigger picture.
Transportation.
Thank you so much. Transportation industry. What else? Environment, okay. Highways. Because if you make a flying car, would you think highways have to change? Infrastructures have to change. Stoplights have to change. Police department have to change rules. You know, the air, petrol. I could keep on going. So these are all the super system. The bigger stuff. The weather, you know, environment. All these are bigger. Sub are the smaller stuff. And we have to look at the past, which is our current now, and in the future, and in the present of this idea. Sub and super. That's how we get 9. That's how we get 9. Excellent. That was a good introduction. You guys helped me out. So let me just go ahead and jump all the way to the template. This is what you care about. This is the template of the 9 windows analysis. Again, the question is, why do we do this? We do this to have a holistic view of our idea and to predict the next wave of our idea and to see what happened in the past. Maybe there is a pattern, you know, and looking at the smaller components and the bigger components will allow us to innovate faster, as I said, because I could focus now on smaller pieces of the puzzle. Okay, so this is what 9 windows analysis is. So we have the current innovation in the middle. Again, your innovation, whatever you're thinking of.
Is it always applicable though?
No, it's not. 90% is not applicable. The future definitely not applicable because this is where you get crazy. Remember I said, what's that?
I meant the analysis as a whole. Is it always applicable to any innovation?
Of course, any innovation in the world, if you give me, we can do it together. Obviously, mine, it's not like a concrete answer.
Yeah.
You get your own, I get my own. Depends how we think, right? So, obviously, the future is where we get crazy, huh? Does that make sense? We get crazy, meaning it's so crazy idea, because your idea by itself would be crazy, because it's not there. You're the first one to do it. So you got to think about the next step of your idea here. Okay, so this is how this goes. So we're going to do an exercise together in a second, but this is cool. So again, you could read this yourself. Let's do an idea. Let's do an exercise together. Suppose this is a nice exercise. Just makes it easy for you to understand how to fill in the gaps between them. Obviously, we always start with the present. You know, your idea, how it was in the past, and how do you think it's going to become in the future. So we start with row number 2, right? Row 1, row 2, and row 3. Typically, if you go back to the box, let's show you. A common person will start here. Yes, the system itself, because that's the easiest for you to understand. You say, again, I'm going to do it really quick with you, but obviously we don't put only one, we put like 5 or 6 things in each box. The more you put, the more innovative you are, because you could maybe extract from the more. Remember, quantity is so important in these things. So current innovation, let's say flying shoes. Back to our flying shoe, because it's easy to understand, simple, right? Flying shoes. Okay, in the past, the system.
Normal shoes.
Normal shoes today, normal shoes, right? With laces. You can put more stuff, like with laces, without laces. And like some features of shoes today, right? Sports, formal, leather, non-leather, plastic, stuff like this. These are all typical shoes that we have today, which is the past of our idea. Because once you came up with the idea, this becomes past, although it's now. Okay, so you don't get confused, because some people get confused here. So yeah, flying shoes, this is our past of our flying shoes. The future of the flying shoe. Future, like we said.
Be a car. We can push it.
Flying car, yeah, or it could be, no, what's the next wave of flying shoes? If you made a flying shoes today, what's the next wave? Maybe you could be more specific, it could be flying shoes for between 50 and 60 kilograms weight, example. The next one would be for bigger people, like 80, 90 kilos, 100. Yeah, it could be, but let's stick. I know, yeah, it could be teleportation. Yeah, no, why not? Again, get crazy here, but it has to be along the same lines of our flying shoes. Now we come and say, now we do it's like we do the plus sign. Okay, we do the plus sign. We did this. Now we do what? We do this, present and past. Because again, of our system, we can always remember this. We already did now we are in the present. So what do we need to actually come up with the flying shoes? What are the subcomponents? Yeah, so we have hover component, hover mechanical components. Why not? What else? What makes it shoes? Let's look at the subsystem. What?
The material.
The material. Give me examples. Let's say metal, leather, and so on. Light material. Could be light. The battery, yeah.
Power system.
The weight of the person we said because it's related to some things that we need to look at, right? Pressure sensors, a lot of low voltage sensors. So all these are smaller stuff, right? It's called subsystem. The sub things, right? Now the super things. What's this bigger picture of flying shoes? What does, like we said with cars, we talked about a lot of things. What is a super system?
Transportation, like the sidewalks and the change.
Yeah, sidewalks, pavements, the actual ground, because we don't need ground anymore for a fly, right? So, you know, travel range, yeah, it's a bit, you have to be more like a system, but yeah, I know what you mean. So travel range could be, yeah, okay, the weather outside, stuff like this, the bigger stuff, the super system. And now how it was in the past, same thing. We look at normal shoes. What are the smaller pieces? Again, leather, plastic, the stuff I talked about, the things that make it, you know. Super system is the normal pavements, you know, sidewalks, stairs, because you could fly, you don't need stairs anymore. Elevators, that should have been here in the super system, right? Because that's a super system, because elevators will completely be obsolete, maybe, because of our flying shoe. Something, you see how it goes. We could think about it. That's, maybe I don't think it wisely, the idea. It's a bit dumb. But still, you get the idea in terms of what we're trying to do. Let's do a more concrete example. Pataya. Okay, yes. So we're going to do the 9 windows analysis. The idea is this. If you don't know what pataya is, it's super tasty. This is what pataya is. It comes from dragon fruit, which is in Thailand and all these tropical islands, you know, if you've been there. So the idea is what they want to do, they want to determine a way to cultivate the pitaya plant in a colder climate. Okay, one more time. Pitaya doesn't grow in cold climate, only, as I said, in tropical places. In Colorado, if you've been to Colorado, where they did the Winter Olympics, Salt Lake City, and so on, in the US, so it's very cold, super cold. But they want to use pataya and dragon fruit because it's very famous. Many companies, by the way, are using it in drinks because it has a lot of vitamins. So it's kind of famous. So the job to be done is cultivate pataya in a colder climate. So this is where it's going to be in this whole 9 windows.
That's the middle.
That's the center. Thank you so much. That's in the middle. Now I have to start thinking, what are we doing to cultivate in colder climate today, which is the past? What can we do in the future better and vertically and horizontally? Okay. So I'm going to do it with you now. I'm going to do it quickly. Usually in a normal setting, you'd be doing it for like half an hour and then we argue. It'd be like an activity, okay? But I think it's fine. I think we got the idea. Let me go and do it with you. Again, these are not like correct answers. Could be any answer you want, but just to give you an idea how things work. I think I flipped it, by the way.
Yeah, you flipped it first. Then the super system and subsystem before the past and present.
Yeah, but I think even it's going to be like this. I think this is the future. This is the past. So I'll tell you in a second. We'll do it together. Don't worry. You might have to edit this. I'll try to upload. I already uploaded it, but that's fine. Let's look at this. So you want to cultivate pataya in a cold climate, right? So we are here, number 1. As I said, the first thing, again, you could do this or this, doesn't matter, but that's fine. We're gonna do this vertically first, doesn't matter. So what is the subsystem of cultivating pataya? So if I want to cultivate in a colder climate, I'm looking at the smaller pieces that want to be cultivated, right? Think about it for 1 second. I want to cultivate a fruit in a cold climate. I have to look at what makes a fruit. What makes a fruit? What are smaller pieces? Seed, roots, leaves. The soil may be, again, this is a bit debatable, the soil. I don't know where I put it here. I didn't see the answer. But typically, it could be a super system. It's a bigger thing. Or it could be a smaller, because the soil doesn't really make the fruit itself. But again, it could be either way. Typically, I don't know where I put it. I put it up, yeah, as I expected. So yes, typically as a small, what makes a fruit? Like the shoes, what makes the shoes? It's the leather, is the plastic. I didn't say the ground. The ground is like the soil for the fruit, right? So that's a super system, it's a bigger thing. So yes, I think what did I put? I put fruit, leaves, roots. You could seeds. You could add seeds to this. Why do we care? Let me tell you why. Because if I want to make a fruit be resistant to cold, I need to understand the chemical, smaller pieces, the microscopic components of it even. You can even say cells here. You could go down to that level, imagine, sub. Does that make sense? On a super level, yes, you have to look at the soil, the surrounding trees, the tree itself that holds the fruit. Because I might have to put a cover on it to hold the cold weather. So I need to understand the tree components, the climate, the weather, I could keep on going. What else? What's missing here? Look at that stuff. What are the super systems that we missed? I put 3, you could put 10. No, these are solutions. We're not there yet. We're looking at the super things and the smaller things. You see, these are not solutions. These are things affected by smaller parts or bigger parts. This will come. It's going to be somewhere, this greenhouses thing. It's a solution. Maybe even the past. I'll talk about it in a second. But for now, so what else? What's in the super system that we missed? The area. What do you think? The country? Country rules, the laws, right? Regulations. There are super.
Living habitat.
Yeah, exactly. Animals, because they could eat it and scratch it and so on. Yeah, you can keep on going, right? Yeah. Definitely, you could come up with 6 or 7 more. I'm just giving you the tip of the iceberg. Okay, now we look at the past. Okay, I flipped them. So this is, just in case, let me write on top of it, so that we don't, please, if you have the notes. So this is wrong. So this is the past, this is the future. Huh? This is the future. Yeah, but yeah, this is B. Okay, just in case you're studying, just so that you don't get confused. So let's look at the past first. So we're looking at the past. So our system, again, we'll cultivate cold, pataya. How do we do it today?
Greenhouses.
Greenhouses, tents, right?
Controlled environment.
Controlled environment, yeah, definitely. I know what I put here. Heaters, greenhouses, tents. Yeah, perfect, as I expected. Could be, thank you, could be use of specific, because none of us are agriculture experts. I don't expect you to know the solutions exactly, but there are stuff that we kind of know, greenhouses and tents, right? But in case you know, you say a specific chemical that will allow the soil to heat automatically. I don't know, could be sensors here. We don't know existing solutions. We have to do research on this. But I think up to our knowledge, most of you understand what these are, right? Yeah. Without being an agriculture expert. Does that sound good for the past? Yeah, now we go to the future. So if now we want to cultivate pataya in cold weather, what do you think the future would be? We want to cultivate, meaning I want to plant it, The future, if I want to cultivate pataya in cold weather now, maybe in the future I won't, again, I put something here, but you could come up with any idea, but maybe, what do you think?
Maybe
yeah, so what do you want to say? What's the word? Yeah, this is more or less what I said here. So genetic. So I'm playing with the genetics, with the DNA of it. It's not only find a solution to cultivate it. No. I don't want to cultivate, as you said. It could be in a microwave, like you put the pill like Back to the Future. Seen the movie? To touch you, and pataya will come, something like this, Yes, that could be the future. Genetically engineering it. So I'm looking at engineering now instead of planting. So it's not agriculture. Again, this is what we thought. So you could think about anything else. You could come up with teleportation. So I don't need to actually plant it in Colorado, push a button, it comes there. I mean, yeah, again, this is the super future. It's not the future, this is future square. Your future is you now, which is called present, just to be clear. So this is double future, so you could be creative there. As long as along the same lines, you don't want to go away from it completely. So now we go, so we're all good with the plus sign, we did this, we did this. Again, just be careful with the past and the future there. So far so good. So now we start looking at how it was in the past. So we're going to start here, the past. So we're looking at here, these two first. So if you're looking at heaters, greenhouses, because you put this first, right? We put the heaters and greenhouses and so on. So the subcomponents for the heaters and greenhouses and so on are the things that you're talking about, more or less. The smaller things. When you said chemicals, yes, could have been here, but this is a part of it. So again, we're talking about specific sprays. What did I put here? Roots, weatherproof, material, things that make the tent, things that make the heater, the greenhouse. Again, you don't know what they are, but you need to make the subcomponents of these. Whatever you put here, the sum of these will be here. Does that make sense? And obviously the super components, so if we're doing the subcomponents of heaters, greenhouses, and so on, we're looking at, again, soil, trees, and climate. That was what we're looking at here. So the past of this, so in the past, how did we do them? Again, we used to water them, right? The soil. We have to keep them moist and put water all the time. So some kind of irrigation system, right? Heat generating ecosystem. So looking at heaters. So you can see here it's very generic here. The super system is almost anything, but again, yeah, it has to be linked with the column you are in. If here I looked at heaters, greenhouses, and plants, think about one of the bigger stuff for greenhouses and heaters and plants. Typically, we're looking at the soil itself. You know, how do I make sure? Because if I put the tent, the rain doesn't go inside anymore. So I have to think about irrigation. I have to think about water. How do I keep it hot? How do I keep it cold? Stuff like this. So controlling the environment.
Can we approach it by going on the present, going to the subsystem, and then moving to the right?
What's that?
Like instead of going to the past from the middle on the system,
Yeah.
go first down to the subsystem, and then we go to the future, or the past and the future from there.
Usually you start like this,
Yeah.
this, or this.
No, that's not my point. My point's actually done the plus.
We've done the plus. Now, yes.
Instead of going from 3 to 4,
Yeah.
we go from 2 to 4. That's my question.
I know what you mean. You can, but preferably like this.
Okay.
But you can, yeah,
Alright.
sure. Again, we do the same thing with the future. Okay, so we start genetically engineering the plant to go to to work in a bad cold weather. Genetically engineering. So here we're going to genetically engineer. If this was the same idea, genetically engineer what? The seeds and the roots, right? Same logic. Here I'm genetically engineering the plant itself. Here I'll genetically engineer these things because I put these things here because I decided on. If you put something else, you have to stick with what you put. So we are here. You go down and then you go up again. Here we look at the soil, the trees, and so on. We're looking at the soil engineering. So it's very generic stuff. But you can see that once we're done, you look at this picture, you have a very nice holistic view of basically your job to be done, which is in the middle, right? You have a lot of ideas surrounding it and a lot of ways to actually solve, hopefully, the problem eventually. Because you know how it was done. Now you predict how you want to do it today, okay? Up till now, we don't even have a solution to how we're going to do it today, right? All we know is we want to do it. To do this, we need to look at these two things, okay? And this is the research. Are we good with 9 windows? Yeah? Good, good.
Do you want us to apply it for our project? Do you want us to apply it for our project?
That would be good if you can like, do a small diagram, and it would be nice to have it somewhere in the report. Definitely, everything we taught you, we want to see it in the report. You know, SAT, job to be done, design thinking. The more you put, it shows you've learned stuff. You know, not just putting it there. We do put it there hopefully because from the design thinking we're able to find this. From the 9 windows we figured out this component is critical. You know, stuff like this. Yes.
This 9 window, where should we place it with regards to the design thinking and the
Exactly. It comes after we do the design thinking and the opportunity. Already identified the opportunity. Remember? So we have an opportunity gap.
Yeah.
We know that we have to cultivate. We already fetched it from assignment 1. The end of assignment 1 will be this, the next step. I have an opportunity, I want to kind of digest it. I want to zoom into it and zoom out from it. This is what this is. You zoomed into it and zoomed out from it in 3D, in 3 dimensions, you know, 3 by 3. It's not only smaller and bigger, no, smaller and bigger in the past and in the future.
and for the design thinking process?
Same thing, design thinking would lead you to an opportunity. Remember? So you talk to your friends, you want to give them a gift or giving experience. You figured out the best way is they want it to be colorful, a game, and so on. So I got it. I could do now in 9 windows. I put it in the middle and figure out what are the things I need to do in order to make this happen. Okay, so it's the next step after you figure out what you need to do. But you don't know how. This is for the how. Okay? What are the things I need to focus on? Very good. So again, you could have other examples, just quickies, like a computer game, for example. A small example would be, if you know a bit about gaming. So a game, the smaller pieces that make a game, if anybody have done a game in their lives. So you work on objects, you know, you have characters, you have the actual things, call these game objects. The bigger one is the super system for a game, is the PC or the Xbox or where it's going to be in, right, environment. And then obviously in the future is going to be a sequel to this game, the next one, the next version. The idea started here and stuff like this in between, drawing sketches and so on. Okay, just to give you an idea and a smaller example, but that example was more concrete, okay? Are we good? Yeah, so a typical innovator, if anybody of you know an innovator, or if you are one, this is how their house or their apartment or their office would look like. It's all sticky notes, you know? We stick a lot of notes. And these notes are ideas that come to your head. So you write it, you put it down. If you go to Stanford, as I said before, in the D school, all their walls are like this. You know, you have a sticky note. I remove it, I write on it, and I stick it. So I don't forget what my idea is. So again, why did I just show you this? Because this is very useful for something called ethnography. Ethnography is a technique that innovators use in order to extract features from their customers, okay, without sometimes the customers knowing. Okay, so this is what we call ethnography. So ethnography, we'll look at the example in a second, but basically some questions that you're going to ask: what are we trying to learn? Who should we observe? How many observations? You know, again, I am creating a baby crib, you know, for babies. The first question is, what am I trying to learn? I'm trying to see, how do moms and dads use this crib? You know, how do kids sleeping in the crib? You know, baby crib, where they sleep. What's the typical weight of a baby? Stuff like this, right? The technical stuff. That's step one. Okay, so who should I observe? Babies, parents, right? Typically, maybe KGs, kindergarten, daycares, you know, stuff like the baby. Okay, how many observations do you think we need? Maybe 4 or 5 times. I need to observe, visit, and different kinds of babies, you know, different cultures maybe. So you can see, so we need to answer these questions. So ethnography is a process. Typically, we end up like putting a camera somewhere, you know, recording and coming back and watching it, especially if it's public, because it gives us a lot of ideas that we never thought of. You know, wow, look how they use it. Wow, I didn't think about it. You know, so this is a step, part of design thinking. Remember the observation, you observe. We called it observe even. So that's a big part. When do we do the observation? Is it at night, during the day, at different periods of time? So you have to put these, you put them as a plan. You need to understand these questions. So typically exam question as well. We have a study on ethnography on ta-ta-ta. And I ask you, how many observations? What should we do? Who should we observe? You cannot say everybody. But you have to know your customers. Who are the customers as per se, okay?
How all the questions?
What's that?
Do you expect us to know these?
Yes. No, the answers.
No, the answers, but the questions.
No. I will ask them. No.
Was it a conducted ethnographic study?
I would say conduct an ethnographic study by answering the following question. I'll help you out, don't worry. So I don't want you to memorize stuff. I want you to understand. But again, don't be generic. Because you want to, like baby crib, or I could be specific, baby cribs in Dubai, for example. You have to understand what are we looking, who is my customer, stuff like this, okay? Sometimes it's very generic, sometimes I make it more specific. Again, how do you conduct observations? It's going to be staged, meaning you plan for the whole thing, or it's random. You know, say, I'll knock on the door, do you mind coming in? You know, like you surprise them. Again, you could justify either. You could tell me, oh, we're going to do this because. It's also about the because many of these could go both ways. You could say something, but I don't agree with you, say, you convince me. Because. So I'm advising you, not only in exams, in life, anything you say, justify. Say why. Why did you say that? Not because I wanted to, okay? How would you record them? Do you need permissions, right? Sometimes you need permissions, sometimes you don't. So let me show you an example quickly of ethnography. Yeah, let's do the laundry. This is a nice one. Anybody live in the dorms before? You have laundry? How do you do your laundry? Is it in the apartment or you have a laundry house?
There's a laundry room.
There's a laundry room, like in the US, right? So let's watch this. This is an ethnography study. I'll tell you what the purpose of this is. Okay. You see, the part of the ethnography is we label them into categories: observing, collecting, you know. Let's watch them. And at the end, you tell me what you get out of this ethnography. That's it. This is nice. Okay, this was done by students, by the way. This is part of their assignment, ethnography. We usually do that even in the course sometimes. Anyway, so what do you think? I mean, did you get stuff out of this? Like you see, it's what, 2 minutes? In 2 minutes, we really benefited from a lot of things we never thought of, right? So what are the things? What are the insights? Insights. See, remember design thinking? Part of it is observe. Again, ethnography. So what are the insights? Yeah. Takes time.
How many processes like you have to do?
Yeah, you have to do a lot of things. So obviously, if we could have one machine that does everything, right, in the future. Weather outside, it was raining. Again, you can see it takes a lot of time to folding. You can see weight, right, so heavy. Detergent, you saw the detergent. You have to put the soap and you have to put this. Why not have soap automatically in the laundry? A lot of things. I could keep on going, right? So the idea is in 2 minutes, we observe, we really get stuff that we never thought. We want to make a laundry machine. But we didn't know what exactly how things are. We did an ethnography study. So who did we observe here? If you want to go back to the questions. Everyone, anybody that's choosing laundry, but typically students, maybe a teacher, maybe this is the dorms. Could be like only for students. Maybe we're designing it for, it could be different locations. Suppose I want to observe, I want to do two observation, one as a student, one as a grown-up, because the student doesn't fold it like the old guy. You see, he puts it. The student puts it like a bowl and start playing basketball with it, right? Because everybody has their own way of doing stuff. But you get the idea, right? Of ethnography, and part of ethnography is extracting insights, like we did. Typical final exam question, by the way, where I give you a picture. I'm gonna take a picture of something. You're gonna see it,
What can you see?
But what can you see? What insights can you come out of it? Yeah, I remember we did something like this in the design thinking. One of the slides, we had like pictures, they start talking. Something like that. Yeah?
During our online class, that's what we did.
We did that as well. Yeah, we did one activity there, I remember. Yeah, and we did one also in class where we did actually trying to get a book from, I don't know if you remember one of the pictures. So sometimes a picture tells 1,000 stories, right? So the question is, an innovator can see sometimes, others cannot see. So these are part. So again, this is a video, but could be a picture as well. If you talk about ethnography. And it could be involving interviews. It could be, I put another link here, you can check it out yourself. But the idea is, what are we trying to learn? As I said, what are the observations? How do we record them? Do we need permission? So we break it down to a series of tasks. Like we did now, we saw folding, putting it, taking it. Yeah. So you have to always understand, it's not like put the video here and say, I go. No. Take it into stages. Whatever you're trying to do, this job, in this case, it's basically do laundry and go back home. That's the job, right? So in between, you have stages. And this is exactly what they did in the video. And we do that to be live. And we try to understand each stage separately. How long does it take? How does it work? Looking at the processes, how can we do it better? Do something called a task analysis. Again, what are the tasks involved? We decompose the actual job into smaller jobs. Like divide and conquer. I have a bigger job, make it smaller jobs. And then I take every job separately or every task separately. Okay, this is what ethnography is all about, okay? So again, obviously stakeholders are everybody involved in the project. If you've done project management, you know what stakeholder management is. So again, from the project leaders to the customers, to the suppliers, to the investors, all the way to the competitors even. They are stakeholders because I want to see how they think and how they're involved in this actual project. So who buy the product, who pay the bill, who invest in it, who need to store it. If I'm making a phone, I'll give you an example. Obviously, part of the stakeholders who make the purchase, who actually, if I'm looking at an iPhone or a phone, who are the stakeholders? Users, that's step one, right? Developers who make it. Retailers, that's good. Suppliers, supply chain, because I have to look at this phone, how big it is. Almost everybody involved in this whole development cycle of this phone until it gets to the market, even after it gets to the market as well, okay? That's what we call stakeholder analysis, okay? So you could have, looking at who are the stakeholders, like in this case, they're taking a picture of the vacation. We did an example like this before. If you remember, Maha, we've done a customer scenario for her. She wants to go to vacation and share with her friends her pictures. You can imagine now we see Maha. This is Maha and sharing her pictures with her friends. You can do some kind of analysis on who are the stakeholders involved in this exercise, okay? Just let me show you. So just don't worry about these for now. Okay. So once we actually conceptualize the opportunity. So if you remember the gates, right? These are the gates. And if you go back to all the techniques we use the Kagan-Vogel approach, which is the famous one, the 5 identify, understand, all the way to launch. You have the design thinking, which is very similar. At one point in time, we have to create what? At one point in time, both of them. Once we come up with the idea, prototypes, thank you so much. We call them concepts, right? So this is more or less what product concepts are, right? These are concepts. They're not the actual thing, they're prototypes, they're not working, they're not functional. They're typically in pen and paper most of the time, or 3D design, like you did in assignment 2. So we are at a stage to come up with concepts, okay? You want to call it stage 3. So again, we created the POG, we refined it. POG is product opportunity gap. We refined it, meaning created a better POG. Remember, POG starts as a small opportunity, and hopefully, as I do ethnography, I do empathy, I do a lot of things, I refine it and make a better POG. As we go on, we have an idea about the attributes. Where do I get the attributes from? For what technique? What technique?
Line window analysis.
Line window, not maybe the attributes, no, but what? Value quotient analysis. Remember, we put the attributes down. That was my x-axis. This is where I figure out exactly what to focus on and what do I want to minimize, what I want to maximize. Remember the grid, So these are things you have to keep in mind. So we did these. We brainstorm. We get a lot of concepts, right? At this stage, you're gonna come up with tons of concepts. Concept 1, concept 2. Remember, I said quantity. It's not quality. Okay. At this stage, how many concepts usually you get? We said there is a record. Remember?
Oh, yeah.
Yeah, in like 2 minutes, 3 minutes, about 27, I think, right?
Yeah.
27, I think, or 22 or 42, something like this, right? In what? In 10 minutes. Imagine, right? When we did the design thinking, said who can do it? Some of you came up with 15 and 17 and 20, right? But it's good because you're coming up with concepts. You're drawing concepts, next one. And usually in a normal setting, we stick them on the wall, sticky notes, and then we start brainstorming with the team and figuring out which ones we kill, which ones we combine. And we get the stakeholders to say, come guys, what do you think? I like this, I don't like this, but this, stuff like this, more interactive. I'm brainstorming, we do some kind of quick evaluation of the number of concepts we have, hopefully about 40, let's say 40 concepts here. And then we kind of filter them a little bit. We get about 3 to 10 promising concepts. Okay, and how do I filter them? As I said, stakeholders, customers involved, you and your teammates, and so on. We get about 3 to 10 promising concepts, and now we do a detailed evaluation. This is a quickie. Quick evaluation, it's not detailed, it's more like a small diagram with some features, and now we do a detailed evaluation. Detailed evaluation, we're talking about 3D design, we're talking about pen and paper, sometimes like plastic and so on, so that we have a better understanding how it's going to look like, how it's going to be functional, and maybe look at engineering aspects of it as well. We don't engineer it just yet, we look at the technical features. And hopefully, we select one winning concept. And this is the one that takes it to market, okay? This is typical stages that you end up doing in innovation. So when you talk about concept generation, as I said, you can see even here, I mentioned, we try to come up with 50 to 100, ideas and concepts related to what? Related to? To the opportunity. Thank you so much. So, as I said, everybody, when we started this course, I have an idea. I have an idea. I said, no, no ideas. I don't want ideas. What do I want? Opportunity. Because from the opportunity, what can I get? What can I get from the opportunity? 100 ideas. You know, this is what I'm trying to say. This is what people need to understand. You know, when people come up with Uber, it's because there was an opportunity, and Uber is only one idea out of hundreds. There are many others that could have figured out a way to use people to become drivers. You know, there are tons of ways. You know, that was one solution out there. Does that make sense? Okay, so how do you create prototypes? Again, typically you want to create them quickly. Again, inexpensively. You don't want to spend too much money on it. You want pen and paper and scotch tape and so on. Just basic prototypes that will tell a story. Again, we need to be able to reassemble them. You know, I don't like this feature, put this here, put this. You want to make it concrete and static. You want to make it more fragile and agile. You want to make it more agile, meaning I can change it as I go on, okay? So, for example, if I told you there is, well, think about ideas for paper fastening. You know, I want to bind papers together, right? Very quick, before you see the pictures, how can we do that? I have papers, I want to put them together. Staple them. Paper them. And so on. I mean, let's see the story behind it. These are all ways, right? See them? See the designs? These are all ideas that people actually made. I can keep on going, I can keep on going. Again, you know, and even so on and so on. These are all concepts. You know, some of them made to market, some of them failed, some of them passed, some of them stayed, and so on. But this is how ideas start, right? So I could keep on going. You could come up with further ideas. I could even put stone there. So you can see sometimes it gets crazy, sometimes it's simple, but these are all concepts. At the end of the day, they're concepts, no? You could glue them together. You know, you could use rubber bands. You could use stuff like that. Keep on going. Right? You could make holes in them. You know, this thing, you make a hole in there, and then you put it, and so on. But at the end of the day, these are all concepts for the same opportunity. It's not the same idea. They're ideas for an opportunity, which is basically there is an opportunity to bind papers together. So people start thinking. It was incremental, right? Somebody came up with the first one, somebody came up with the second one, and that's all. But all of them are trying to solve the same problem. Okay? So this is how we talk about prototypes, we talk about concepts. So when you talk about concepts, you need to ask yourself some questions. So what are the key value opportunity, the added value of these concepts, the value opportunities, and what are the attributes I want in them? As I said, what attributes I want in them, and which ones have these attributes, right? The more attributes you have, the more compelling the case would be, right? So, and again, how do we know the attributes? From the opportunity gap. We said we want it to be cheap, we want it to, I don't know, fly. These are two attributes, right? So if I look at this prototype, I said it's not going to be cheap, it's going to cost me $20,000, we kill it. Because one of the attributes that we wanted was being cheap. You know, it's not made from cheap material. So we do sometimes sanity checks. Sanity checks is the first thing most of the time you end up doing at the beginning. Sanity meaning, are you insane? You know, ask you a question, it's yourself this question, would somebody buy this? You know, second, quick sanity check. Then obviously you can go to the technicalities. Is it technical? Is it feasible? Is it competitive to others? And so on and so forth. Okay? We iterate a lot, we refine a lot, we get customer feedback a lot. Remember the whole design thinking? We always want to involve the customer. So I do it first time, I iterate again, I do it second time, third time, fourth time. And this is so important. I love this. I love this. I want to remember one thing, and I've said it from episode 1, lecture 1. Fail quickly. Okay? And move on. Fail quickly. Don't fail later on. Sometimes, ironically, this doesn't make sense too much, no? Some people say, don't give up. I'm telling you, give up. You know, if you're an innovator, you have to give up. And move on. Don't give up like kill yourself and jump from the balcony. No, give up meaning go to the next idea. Because you have concepts, right? Khalas, fail. Don't, I don't believe in this. I believe I spent 3, 4, 5, 6 years doing it while others are somewhere else. So fail quickly and move on is a very important saying in innovation. You can even, it's a quote, it's a famous quote. Fail quickly and move on.
But so how do you define it? Maybe it is a good idea.
Again, this is the problem because you don't want to give up on it. You have to give up. Or use what worked in it and ditch it. And use, you know, like you have an idea that worked, take this piece of it and kill everything else and you could add it to the other version. You know, because you have 100 concepts, right? If you're not going to give up on 100, you need 100 years to actually make it work. Okay? Again, obviously, once you have a product, believe in it, of course, once you make it happen. So again, when we talk about prototypes, just real quick, they're comprehensive, okay? They have typically indefinite scope, meaning the scope is not defined well, you know, because you really don't know exactly what the scope. It's not like I want to do this only. No, sometimes you have to add to it. So you have the in scope and out of scope, you know, like an normal project. So you kind of try to make it a little bit indefinite to add as much as you can to it. And obviously it's kind of the beta version. We call it the first version of your actual project. So again, final project in this course, we're looking at the beta version of your product, whatever it is. It's a beta. It's not functional, huh? No, but something has to work in it. Nothing. If nothing works, then your grade is nothing. I'm not saying, if I, again, making flying shoes. Today is all about flying shoes, guys. We have to call the episode, if you don't mind, flying shoes episode. So if you're doing a flying shoes, you're not going to make a shoes that flies. I know that for sure. But maybe a small Barbie shoes that flies to an extent. It doesn't fly 5 kilometers, flies 2 meters. And then you explain the concept behind it. Something that proves, because you claim that your idea is innovative because you're making a shoe fly. But if you don't prove it, that's a proof of concept. That's fine. I want to see what is the newness, if that's even a word. Concept doesn't sell, my friend. And many people, the janitor outside, if you go to him now, he has 20 concepts. That's the point. I want you to have an idea. It has 50 features, right? I don't want 50. I want one out of the 50. And I don't want anyone. I want the one that separates you from the existing. Does that make sense? If you claim I'm making a table that unlocks using biometric of the student, for example. Coming up with ideas today. Okay, so the student puts it here, this opens so that you don't allow students that are not paying their fees, the admin, to come and attend lectures, right? They will be standing. It looks awkward now that they're standing. What is this? Opens. Your friend, if he tries to open, for example, I'm not giving an example. Cool idea, yeah, you could invent it easily. You only use a biometric device, a nice motor lock that allows it. I think we can do it. It's unique. It's definitely unique in my opinion. I don't know. I didn't even Google it yet. But that being said, if you want to demonstrate a prototype, you will start with a desk. You're not going to make the whole system with database and so on. You will get the fingerprints biometric. You're not going to invent it. It's already there in Souk.com, any fingerprints. Now the question is, we need some kind of a processor you're gonna put it, but it's gonna be so basic. It's like I put it, say hello Muhammad, but this will not open. It's not so difficult. You need a mechanical guy and so on. But I know that it could be done. I mean, I could hire a guy for 2 minutes to do a motor that opens up and closes. But you prove to me, if I put my finger, say hello Muhammad, and my name comes here, means that the concept is there. Does that make sense? You didn't make the actual thing. You made the concept. I understand how it works now. And it's doable, and I believe it's doable because all the features of it are so simple. You know, does that make sense? Or if you don't want to do biometric, you could flip it. You say, put the plastic thing here. Say, this is a biometric device. You could buy it from off the shelf. I'm like, okay, cool. I put it, and you did the motor. You did the other side of the story because you're a mechanical guy, and you push a button. I have to push it. To push it, this goes, it opens. Well, I get it. You say, but of course, the actual thing to be connected to the biometric device. So, but you have to do something. But if you don't do anything, just put a paper here that says biometric desk. Okay, thank you guys. You know what I mean? I don't want people kind of to insult my intelligence a little bit. Say, yeah, this should do this should do this, and this should do this. Okay, but yeah, I get it. You know, but I need at least something in that whole big project of yours, gonna be big in my opinion, that is functional. You know, if it's an app, I have to see a mimic of the app, you know, a small version of it, maybe not all the features of it, but at least one feature, if I push it, something happens. Oh, I get it. And he said, there are 6 icons, you know, 6 buttons. We did 1, the other 5, obviously, we can do them. You know, we're not experts, we're not computer science people, but we did our best. We hired people, we helped them, but we did 1. Now you get it, I get it, and the others you could fake it. Meaning if I push it, something static will come, like an image, as if it's actually working. But at least one thing has to be working. If nothing is working, then you didn't put any effort whatsoever. All you have is an idea and some pictures of it, okay? The more effort you put, the better it is. But you have to remember, this is a very good question. Maybe it's good we're recording this, if the others are seeing this as well. For prototypes, you don't want to have a prototype that's 90% complete. You don't. You don't want it to have, what do you want it to be, the prototype?
Just a working model.
Yeah, so how much percent? No.
Well, at least 50% of the.
No, I would say 20 to 30%. You never want it more than 50 because that will really kill the project, because I would believe that this is the actual thing. You don't want me to believe this is the actual thing. You want me to understand this is a prototype. You don't want to become as close as possible as you want to the real thing. No, that's a bad thing. If people would think, if I come close, it's good. No, it's not good. You want me to understand what the features are and give me a taste of it. That's the 10, 15, 20% I'm talking about. That's all I want. Not only me, even a normal investor. When you come and you kind of kicking off a project, when you talk about prototype, you want to go away from it. You don't want even to be coloring it the same, or because you don't want to think about these for now. Because sometimes it might distract. It's a bad thing, as I said, because the audience or the investor or whoever the person is will, because if it's very close to the real thing, he would believe this is the actual real thing. And what if I don't like it? But you I say, the color is bad. It's not ergonomic. Ergonomic meaning it's not comfortable. Because they say, no. In the future we're gonna do this. But you made me believe this is the thing. No. From the beginning, you need to be clear. This is a prototype, and make it far from even not look. Say the next version is gonna be smaller and so on. This is fine. Here this is what it's supposed to do, and this is a proof of concept of one of the features. And you're good to go. What happens beyond this is hopefully the engineering team will be on board, because you guys are innovators. You have to remember, you're not engineers anymore. Then you hire people. You have a team of engineers that come here, they get their hands and start cutting and making stuff happen, Okay, sounds good? So look at prototypes a bit quick. So these are the very alpha version, if you want to call them. You can see this looks like a gun, right? You could hold it here. It looks like it as a start, right? These look like buttons, right? You could push them. If you look at this, you have an idea, right? It's like maybe a barcode reader style thing. You have an idea. Again, this looks like what? Of course, like a camera. Although it's not a camera, but again, it gives you an idea what you need to do. Obviously, you could do 3D modeling. That will make it more in terms of design. You could have apps. For example, this is funny. I love it. This is a creative way. He did this. Let me see. This one, I think, of a prototype. Just a funny thing, but it's nice how they thought about it. I like when people come up with ideas just to. Oh, not this one, maybe. Oh, this is. Oh, not this one. The other one. You can check these links out. Oh, not this one, maybe. Let me write them the link. The other one? I don't have it. But I had a cool link. Maybe it's somewhere else. But anyway, so you get the idea. So prototyping is obviously important. Give us an idea. This is a prototyping using Photoshop even, not even 3D. But it looks like 3D, right?
Yeah.
It's not 3D, but you could use like a thing. I put the link how to do something like this if you get with Photoshop. How to fake it to become 3D. This is a nice example of a 3D model. You can check this out even as well. Very quick. A project of a nice idea of a chair that changes. I think you see in 3D sometimes give you the illusion that this is the real thing. So it's cool. So 3D prototyping is very useful. You kind of save a lot of money when you do 3D prototyping as well, so because you don't have to actually do the real thing. Okay?
Doctor, before coming up with the final project, we have to check for the value of opportunity as well. If there is an opportunity, then
of course. Hopefully you are continuing the assignment one. Hopefully, if you're not continuing assignment one, you have to at least do some value opportunity.
Then only we have to.
You change your assignment one. If you changed it, yes, you have to redo it, but not everything. only the value quotient analysis to prove that, yes, this is really, there is a value. That's why we taught you this whole thing. Otherwise, why do you need it? If you continue assignment 1, so already in assignment 1, you already proved to me that there is a gap, right? You remember from assignment 1. Okay? So obviously you have to limit our prototyping because it takes time, money, and resources. And again, it's not the end itself. This is what I was trying to say in a second. It's not the end, it's a means to an end. So always think about it as a means, just proving a concept. Again, when the engineers come in, most of the time they're going to scrap everything you've done and start clean and design it, because that was only a tool to convince people that what you're doing, it's really going to work and it's very useful and meaningful. Okay? Again, temptation to turn a prototype into a real thing. There's always people tempted to do this. Obviously, don't be tempted because it's not the real thing. It's only a prototype. Okay, this is interesting. So as we go over time, you can see the number of concepts that we look at. So we start with 100 concepts, right? As we go over time, what happens to it? It decreases, right? Until hopefully we get to what? 1. Thank you so much. So this is typically 1. This is 1, hopefully. And again, the fidelity meaning how long would they live before you kill them, okay? Again, it's inversely proportional, right? So we start initially, they don't live too much, we're gonna kill most of them. Hopefully at the end, this is gonna be the winner, and this is gonna go to market. So this is a nice graph. I like these kinds of exam questions. I give you a graph, I say label this, what is this graph, what is this, how does it affect, stuff like this. It shows that you understand what you're talking about. Does that make sense? Yeah, cool. So here we say this is where real prototyping between codes, meaning more or less the engineers are on board. We try to prove the code because you only have typically 1 or 2 or 3 of them. Remember, we start 50, then we go to 3 or 5, and then we kind of do some kind of more detailed prototyping. So what kind of questions? When you do prototyping, like we did with ethnography, this is important. Please pay attention, guys. This is important. So when we do prototyping, we have some questions we need to answer, right? Why are we doing the prototyping, right? So what are we trying to answer? What attributes do we have? So does your concept hit the market or hit the mark with the target? Will the product solve the problem that you identified to start with? Does it solve it? Is it feasible? Will the solution fit in the target tech ecosystem? So important. There is an ecosystem technology. So you cannot come up with a completely new technology, and many things happen, right? Like Apple, you know, when they came up with not the USB, the other thing. What does it call it? The lightning one, whatever that is. So again, does it fit in the whole ecosystem of the world? It doesn't. Did they ask themselves the question? Yes, they did, because their goal is different. It wants to fit in their ecosystem. So you have to ask yourself these questions, again, because you're not Apple. You cannot come up with something you know where you take it. Apple can't, because they have their own ecosystem of their own they built, right? But typically, anything you design or develop has to fit with the ecosystem, like Bluetooth. Suppose I come up with a new wireless technology, not Bluetooth, I don't know, white tooth, okay? And now it's way better. Think people would use it? Because if it doesn't fit with laptops and it doesn't fit with your phone, who cares, right? And that's why you have to go back for people and say, please add my standard to your thing. Otherwise, like NFC, right? Near field communication. Sometimes it fits, sometimes it doesn't, like paperless or payless or cashless. All these things are very question markable stuff. So back to this, why do we care? So a typical exam question or a typical life question is you want to design something. I want to design a baby crib. The first thing is, what questions do you want to answer in the prototype, right? You need to ask yourself, I'm making a baby crib that does something, you know? I'll give you an example, you know, whatever, the baby crib that vibrates when the baby cries, you know? So you need to ask yourself, what are the questions we need to answer in the prototype? Why am I doing the prototype? You have to remember, the prototype is what? Yeah, it's a means to an end. This is what you have to always keep in mind. We're doing it for a purpose. The purpose is to answer what? The questions. That's why we did it. To prove a concept, right? So you have to know what questions. For example, the baby crib question would be how much does the baby weigh, right? What voices? What would it function? Is it on battery or not battery, right? How fast is the vibration? Something like this, right? You're gonna ask these questions. You know, what are the medical requirements? You know, because I might shake him too much and he gets dizzy and something happens to him and they sue us, right? So you have to ask these questions in the prototype. That's why we do the prototype, to see. You know, and when would he sleep? When would he stop crying? stuff like this, or interoperability, right? Will it work with the phone of the parent away from them and stuff like this. And again, once we do that, these are the questions we're going to ask, and you have different kinds of ways to do this. So what are the prototyping techniques that we have? These are the prototyping techniques. You can use pencil, paper, whiteboards, they're all very quick. Photoshop, HTML, 3D Max, storyboards, physical mock-ups like the ones you saw with paper and pen, like we did in design thinking, technical prototyping, where you actually look at the technology behind what you're doing, So all these are quickies, not even for the beta version, I would say the alpha version, the one that comes before it, to give us an idea what the prototype is. So again, it depends what you're doing. If I'm doing a barcode reader that has X-ray in it, for example, yes, I could quickly do it, like we saw now with the pen and paper. If I'm doing like a baby crib, you cannot like make a Barbie baby crib. It doesn't really give away. You have to maybe go more 3D modeling first, so the type of prototyping that we're using and the question that we have to ask are very important before we actually do any kind of prototyping, okay? Of course, you have to be physical. For you are not doing a beta version for the project. You're doing let's call it a gamma version, the next prototype. Okay, it's not paper. It's not going to be paper and pen, as I said. It's going to be a little bit advanced. Step one. Okay, and you could retrofit. Existing things. Like if I'm doing a desk, you could start with a desk and retrofit it. For example, I'm just kidding. Okay, so yes, we had amazing projects before. I'm not gonna lie to you. Amazing. People got stuff here. I remember they got. I'm giving you examples. Okay, again, baby crib, for example, that was one of the things they did. An actual baby crib. They had a bed of a baby that, as I said, baby cries, it vibrates. It measures the temperature of the kid. If he does something, they figured out. They put like, water or something, and it beeps. The color changed because we knew that they didn't. The parent would come. So it was so amazing, It was patent pending. This thing with the feature, they had some unique features in it. Another example, what did we have? We had for elephants, not for elephants, for horses, a device that provides food to horses. They had a farm here somewhere in the UAE. Because now the way they put the food, I think they put it like this. They did a machine that goes and knows as a schedule, figures out when the horses are hungry and not. Something like this. I don't want to just give you ideas because it deviates you from what you're doing, but they actually did it. They put it, and you see, like we tested it, and we did it. We saw everything's working. It was very, very cool. I could show you tons and tons of videos.
They show you a video of it working, or
they show me the actual prototype here. We tested here. I tested. I really tested.
Actually working?
Yes, not 100%. Again, one of the features working. Yeah, we had. What did we have also? Like can opener. This is a simple version, for example. Can opener using laser. Don't do like this. They put it like this. You push a button, it goes. It cuts it automatically for home use. They use a very basic laser. For example, I'm not giving an example. There are many things.
They use an actual cutting laser.
Yes, a cutting laser. But very basic model. It's very thin. It just cuts. It's not very dangerous. This is like a home thing. Okay. I don't know if I have videos here. I can show you later. But yeah, let's do a cut now. Let's take a break. I'm a bit tired. We'll continue after the break. Okay, are we good with what we did so far? So all this is recorded, all right? So let's stop it now. It's 1 hour and 18 minutes. This is the first session.
How long is the break?
Let's do about 15 minutes.